Hello and welcome everyone to another coding tutorial, but before we jump into the code, I want to introduce you to the problem. You might want to code something with a voicing system and run into the situation where you want to suspend voices that are currently not in use in order to save some CPU. Bitwig has this feature for its tracks. So you can see here in the mixer view that all of the modules and plugins that are currently not in use have this moon icon, which means that they're currently asleep. And if we are playing back the project, we can see it turning on and off. For some reason, EQ Plus goes to sleep very quickly, but the convolver doesn't, and the compressor never goes to sleep. I don't know why. But let's not question that now. Instead, let's just move on. So here is my plugin Hammer and Meiszel, which I have already released the moment I released this video. But this is a very early version of the plugin because I have recorded this video a long time ago. So don't be surprised that it doesn't even have a GUI and only a few parameters. But at the moment, it sounds like this. So you can see there are constantly notes on the 8th notes, and sometimes you just don't hear them. They seem to be choked. So this is the important piece of code in question. If I comment this out and only have process block here, then it will process every voice at any time. But since there are 15 voices and each of them has a lot of filters in them, it wouldn't be very good to let them process all of the time. So I needed to come up with a system that automatically turns them off if they're currently not needed. So my initial idea was just to say, okay, if the MIDI buffer is currently empty, so there are no note ons or note offs, and also the voice wants to sleep currently anyway, then just return immediately, and else you process the voice with the envelope, with the resonator, and with the auto gain value, and then after that, you might be in the situation where it is already silent because the envelope has already faded out and the filter as well. It is about detecting if the plugin should go to sleep. And as you can see, my detect sleepy method works like this. We check if the buffer is silent. If yes, then we go to sleep. If we are not going to sleep, we can return. But if this voice is now going to sleep, then we also clear the voice. But yeah, as you have heard, this didn't work. And I've been working on a bug fix for like 2 weeks and it has driven me crazy, and only today I found the solution. And in this video I want to show you the way how I found the solution, so that if you are developing literally anything, you can maybe learn something from it. So first of all, I tried to come up with a way to make the bug reproducible in a controlled way. So let's activate the plugin and just check out when it happens. So we can see it happens on the second note of the second bar, and if we deactivate and reactivate the plugin and play back again, we can check if this is consistent. So we can see that this is in fact consistent, and this enables us to use breakpoint debugging. To do that, I will just make an oopsie. MIDI is empty. Do you want to know what oopsie means? Oopsie means opposite of just I invented that because I feel like I want to ask for the thing that should break the code and not the thing that does not break the code. That's just confusing. Why would I ask for the thing that I don't look out for? So yeah, oopsie is the opposite of just So now it will trigger a breakpoint whenever the MIDI buffer is empty. That's not what we want. We want to find out whenever it is not empty. So let's build this thing. Alright. So now we can activate the plugin and we can activate the process. And now we should also turn down the master, or else we will have to listen to the sound constantly while debugging. Now I press space and we can see the breakpoint is it. So let's make this window a little bit smaller so that we can see how it progresses here whenever I hit continue. Continue, 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 continue. And now we see it moved on to the note of message. I had to press it 5 times because this track is currently playing a chord with 5 notes per note. And 1, 2, 3, 4, 5. Now I just go on a little bit fast forward here because I know what I'm looking for, right? I'm looking for the second note of the second bar. So I can just go on for now. Okay, now I have to be careful. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now I'm exactly on the state that I want to inspect closer. So I can go on here and I could check out, yeah, what's process block doing? Step into process block. Doing that. What's synthesize envelope doing? Let's find out. Boop, boop, boop. Look at the first MIDI message. It appears on timestamp 27. How many samples do we have? 32. That makes sense. So it is a note on message. So that's correct. We are going into the note on case. Sample index becomes 27. Synthesize envelope has happened, which, by the way, puts stuff into the envelope buffer. We can see it's all zeros because the envelope was turned off at that point, and only when it has reached the number, what was it? 27. It will from that moment on continue putting values in here, but only later. So let's go on. Boom. Do we have more messages? No. So now we can go into synthesized envelope and keep on synthesizing the envelope. Let's look at what the envelope is doing for us. So we see some extremely small values building up, growing larger with time. So we can step out of this method. We know that it works. We can step out of that method. We can process the envelope. Yeah, let's check out that as well. We will not be able to see a lot here because there is an SIMD method which just skips over the entire process of multiplying the envelope with the signal. So let's just go out here. Will not show us anything. Then there is the filter. Let's step into it. Filter also looks at all of the MIDI messages and it finds the note on. Boom. It finds out that the pitch is 66, that the frequency is 370 Hertz. It sets the frequency. Boom, it's a new frequency. Iterate over all of the filters. Still 360. It has the FC value of blah blah blah, some small value. It updates the resonator. Everything looks okay in here. So let's go on. At the end of the method, we are applying the filter. Does this work? Let's find out. We have a wet sample, which is still 0, and the dry sample is not 0, but it's an incredibly small number since we have multiplied the envelope onto it. So let's go on, looping through all of the filters, adding stuff parallelly. And then, oops, I've already clicked too far. But yeah, let's just do some of these calculations and then we will see the wet value has some incredibly small but not 0 number. Step out, this seems to work. Step out. Then there is the auto gain feature at the end that's not very error prone. Let's step out of this as well. And then the last step, detecting sleepy mode. Let's step into this and go on. And we could now go on and we find out sleepy true. That makes no sense. It thinks that the buffer is silent even though we have just literally added numbers that were not 0. Now that we found what the problem is, we can look at the buffer silent method and we can find out that the buffer silent method has probably triggered this state because none of the samples in this buffer have yet been bigger than 1e-4. This threshold value might just be too big. Now I artificially changed this to a number that is indeed too high to put a little bit more focus on this issue. I actually had this on -7, I think, or something like that, and it still happened, but it just happened more rarely, so I changed it for this video. Anyway, here is what I tried then. Let's first of all stop the debugging because now we know what the issue is and we can work on it with our minds instead of with our IDE tools. Stop playback, deactivate. Now the first thing that you can try in a case like this is first of all to say, is the buffer too small to even make a decision, which would mean that num samples is smaller than the desired block size, which in my case is 32 because I have an internal block size in my plugins. And yeah, it might be that you are currently on a num samples value of like 1 or 2, so that you can really not say that it is a silent buffer just because those 3 samples that you have checked might just be on a 0 crossing or something like that. So yeah, when there is not enough data, then it will just return and not change anything anything about the sleepy state. But that's not actually what has fixed this problem. The actual fix came from this change, where I said, okay, let's look at the state of the envelope, and if the envelope is in fact not in release state, then it is just impossible that this is supposed to be sleeping, which is why sleepy equals false. I don't know why it currently says that this is not possible. All right, I know, I am in the wrong method. This belongs into detect sleepy, of course, and it happens before checking if the buffer is silent. So the buffer silent check is only needed when these two have failed already. So let's build this solution and just check out what it does for us. Perfect. So now I could even keep the threshold on this pretty high value. I still have to listen to all this with headphones before I make a specific decision in regard to that. But of course, a higher threshold value would trigger the sleepy state earlier and for that reason also save CPU. I do want to have rather smooth transitions between sound and silence though, so yeah, I really have to check for that. What I want to say is just tweaking the threshold value is not the solution when you have a voicing problem like this. You might also wanna involve the other things that you have around in your project to find a suitable hack to make your implementation solid, and this thing really solidified it fully. I haven't heard the bug ever since again. Yeah, breakpoint debugging. It's kind of not the most advanced topic of all time, but I think sometimes it is just important to remember the simple things. That you can just look at how the instructions run in the code step by step, and at some point you will just see something that will surprise you, and this surprise will give you an idea.